preparing for an AI workflow engineer interview. You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is an AI workflow, and how is it different from traditional automation? An AI workflow is an automation pipeline where one or more steps use probabilistic AI models, not just deterministic rules. I usually separate it into triggers, data preparation, model or agent calls, validation, routing, and output actions. Unlike classic workflows, AI workflows need confidence thresholds, retries, evaluation, and human review because outputs can vary. The engineering goal is to make model behavior reliable enough for business processes without pretending it is perfectly deterministic. While answering, focus on triggers, data preparation, model calls, validation, routing, and outputs. Contrast deterministic roles with probabilistic AI behavior, and mention evaluation, confidence thresholds, retries, and human review. Question 2. How would you design a reliable LLM-powered workflow for processing support tickets? I would build the workflow as staged automation, not one giant prompt. First, ingest the ticket and normalize metadata. Then classify intent, priority, and sentiment. Next, retrieve account history and relevant help articles, draft a response, and run policy and safety checks. If confidence is low or the customer is high value, route to a human. I would log every model input, output, latency, cost, and resolution outcome to continuously improve the workflow. Make sure to cover ingestion, classification, retrieval of customer context, response drafting, policy checks, escalation paths, and monitoring. Include safeguards for hallucinations, sensitive data, and low-confidence predictions. Question 3. When would you use a workflow orchestrator like Temporal, Airflow, Prefect, or Dagster in an AI system? I use an orchestrator when the workflow has multiple dependent steps, can fail mid-process, or needs auditability. For example, a document intelligence pipeline may upload files, extract text, call an LLM, validate results, update a database, and notify users. An orchestrator gives retries, state persistence, schedules, backfills, and visibility. For real-time user flows, I may prefer queues and services, but for durable background AI workflows, orchestration prevents fragile script-based automation. In your answer, talk about long-running tasks, retries, state management, scheduling, observability, dependency graphs, idempotency, and auditability. Explain why simple scripts often fail in production AI workflows. Question 4. How do you handle failures and retries in AI workflows? Failures in AI workflows are not all equal. A rate limit or timeout deserves retry with exponential backoff. Invalid model output may need reprompting or schema repair. Missing customer data should fail fast. I make steps idempotent, so retries do not duplicate emails, payments, or database writes. I also use dead letter queues for manual investigation, fallback models for degraded service, and alerts when failure rates cross thresholds. Reliability comes from predictable recovery paths. Be sure to mention transient versus permanent failures, exponential backoff, idempotency, dead letter queues, fallback models, validation failures, timeout handling, and alerting. Tie retries to cost and user experience. Question 5. How would you evaluate the quality of an AI workflow before shipping it to production? I would evaluate at both step level and workflow level. For a summarization workflow, I might test factual accuracy, completeness, tone, format compliance, and downstream user actions. I would create golden datasets, run regression tests for prompt and model changes, and include edge cases like messy inputs or conflicting instructions. Before full rollout, I would use human review and limited A/B testing. Production metrics then confirm whether the workflow improves speed, quality, or cost. While answering, cover offline test sets, golden examples, task-specific metrics, human review, regression tests, adversarial cases, A/B testing, and production monitoring. Avoid relying only on subjective prompt inspection. Question 6. What is prompt versioning, and why does it matter in AI workflow engineering? Prompt versioning means tracking prompt text, variables, examples, model parameters, and evaluation results as deployable artifacts. I treat prompts like code because a small wording change can alter production behavior. Versioning lets me reproduce incidents, compare experiments, roll back safely, and know which workflow used which prompt. In practice, I store prompts in Git or a prompt registry, separate staging from production, and require evaluation checks before promoting a new version. Make sure to cover reproducibility, rollback, experiment tracking, environment separation, prompt templates, variables, model settings, and evaluation results. Explain why prompts should be treated like production code. Question 7. How would you implement structured outputs from an LLM in a workflow?
For automation, I avoid relying on free-form text.
I define a schema, such as ticket category, urgency, summary, and recommended action, then use tool calling, JSON mode, or a parser with validation. If validation fails, I retry with the error message or send a case to a fallback path. Downstream services should receive typed, predictable fields, not paragraphs they must guess from. Structured output turns the LLM into a safer workflow component. In your answer, talk about JSON schemas, function calling, output parsers, validation, retry strategies, partial failures, and downstream contract stability. Mention why free-form text is risky for automation. Question 8. How does retrieval-augmented generation fit into AI workflows?
RAG is useful when the workflow needs current or private knowledge that is not in the model.
I ingest documents, chunk them, create embeddings, and retrieve relevant passages at runtime using vector search and metadata filters. The LLM then answers using that context, ideally with citations. RAG reduces hallucination but does not eliminate it, so I still validate outputs, handle missing evidence, and measure retrieval quality separately from generation quality. Be sure to mention document ingestion, chunking, embeddings, vector search, metadata filters, grounding, citations, freshness, and evaluation. Explain where RAG reduces hallucination and where it still needs controls. Question 9. What are the main design considerations when building agentic workflows with tool use? Agentic workflows are powerful when the model must choose actions, but I keep autonomy bounded. I define allowed tools, input schemas, permissions, budgets, and stopping rules. For example, an agent may search knowledge bases, create a draft Jira ticket, and ask for approval before assignment. I log each thought substitute, tool call, result, and final decision for traceability. The best agents are not magical. They are constrained planners inside well-engineered workflow boundaries. While answering, focus on planning, tool selection, permissions, bounded autonomy, state, termination conditions, observability, and guardrails. Distinguish practical tool workflows from open-ended autonomous agents. Question 10. How would you monitor an AI workflow in production? I monitor AI workflows like distributed systems plus model behavior. Standard metrics include latency, throughput, retries, failures, queue depth, and service availability. AI-specific metrics include token usage, cost per task, schema validation failures, refusal rates, confidence scores, and human override rates. I also sample prompts and outputs with privacy controls. Tracing is critical because one user request may involve retrieval, multiple model calls, tools, and validations. Without observability, debugging becomes guesswork. Make sure to cover logs, traces, latency, token usage, cost, error rates, model outputs, quality metrics, drift, user feedback, and alerts. Include both traditional observability and AI-specific monitoring. Question 11. How do you reduce latency and cost in LLM-based workflows? I start by measuring where time and money go: retrieval, model calls, tools, or post-processing. Then I reduce tokens, cache repeated results, use smaller models for simple classification, and reserve larger models for complex reasoning. Some steps can run asynchronously, while user-facing steps may use streaming. I also route by difficulty, so easy cases do not pay premium model prices. Cost optimization should preserve quality, not just make the workflow cheaper. In your answer, talk about model selection, batching, caching, prompt compression, routing, streaming, asynchronous processing, token budgets, and fallback strategies. Tie optimization to user experience and business value. Question 12. How would you protect sensitive data in AI workflows? I protect sensitive data before it reaches the model and after it leaves. That means classifying inputs, redacting or tokenizing PII, encrypting data in transit and at rest, and enforcing least privilege access to workflow steps. I check vendor data retention policies and avoid sending secrets, credentials, or unnecessary customer data. Outputs also need scanning for leakage. For regulated workflows, audit logs and human approval paths are as important as prompt design. Be sure to mention PII detection, redaction, encryption, access control, audit logs, data retention, vendor policies, prompt leakage, and least privilege. Include both application security and model-specific risks. Question 13. How do you design human-in-the-loop review for AI workflows? Human-in-the-loop design should be targeted, not a bottleneck for everything. I route cases to reviewers based on low confidence, high business risk, policy sensitivity, or unusual inputs. The review UI should show source data, AI reasoning artifacts where appropriate, suggested action, and editable fields. Every correction becomes feedback for evaluation datasets and workflow tuning. The goal is to combine AI speed with human judgment where mistakes would be costly. While answering, cover confidence thresholds, escalation criteria, review queues, audit trails, feedback capture, reviewer experience, and continuous improvement. Explain when humans approve, correct, or override AI decisions. Question 14. How would you manage deployments and CI/CD for AI workflows? I manage AI workflows through the same release discipline as software, with extra evaluation gates. Workflow code, prompts, schemas, and model configs should be versioned. CI should run unit tests, integration tests, schema validation, and prompt regression tests against golden examples. I deploy to staging, then use canary releases or feature flags in production. If quality, latency, or cost metrics degrade, rollback must be simple. Safe AI deployment depends on reproducibility. Make sure to cover workflow definitions, prompt tests, schema checks, model configuration, staging environments, canary releases, rollback, automated evaluations, and infrastructure as code. Emphasize reproducible and safe releases. Question 15. Describe a practical architecture for an AI workflow platform used by multiple internal teams. I would build shared platform layers instead of every team reinventing pipelines. Core pieces include connectors for apps and data sources, a workflow orchestrator, a model gateway, a prompt registry, evaluation tooling, and observability. Teams define domain workflows on top, while the platform handles authentication, rate limits, logging, cost tracking, and policy controls. This approach speeds delivery and creates consistent governance, but it must stay flexible enough for teams with specialized use cases. In your answer, talk about reusable connectors, orchestration, model gateway, prompt registry, evaluation service, observability, access control, and governance. Show how platform thinking improves consistency and speed. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.